History credits the visionaries. We find the architects. This is the unsung. Every line of code, every single app on your phone, every digital heartbeat of our modern world can be traced back to a single room in the year 1945. If you look at the famous, black and white photos from the dawn of computing, you'll see something incredible. And you'll also see a lie. This is the ENIAC, the Electronic Numerical Integrator and Computer. It was a 30-ton monster of 18,000 vacuum tubes, a sprawling beast of wires and switches. It's rightfully celebrated as a triumph of male engineering genius. The men who conceived it, John Mauchly and Presper Eckert, are legends. But standing beside the machine in those iconic photographs are 6 women. In the press, they were framed as the ENIAC girls, or sometimes refrigerator ladies, a nod to the appliance ads of the era. They were presented as little more than pretty hostesses for the machine, models posing with a new piece of technology. The truth, however, was buried in plain sight. These women weren't just operators. They weren't just standing there for a photo op. They were the very first people to ever speak the machine's language. They invented the craft of programming from scratch, and then, almost immediately, they were systematically written out of its history. This isn't just about giving credit where it's due. It's just about understanding that the very foundation of our digital lives was laid by hands that history chose to ignore. To understand how they were erased, you first have to understand their world. During the height of World War II, the job title, computer, wasn't a machine. It was a person. And most of these human computers were women, often with advanced degrees in mathematics. Their job was to perform incredibly complex ballistics calculations by hand, charting the trajectory of artillery shells for the U.S. Army. It was grueling, precise, mind-numbing work that was absolutely critical to the war effort. From this pool of brilliant mathematicians, the Army selected 6 exceptional women: McNulty, Betty Jennings, Betty Snyder, Marlyn Wescoff, Fran Bilas, and Ruth Lichterman. They were told very little about their new assignment. They were simply moved to a top-secret facility at the University of Pennsylvania to work on a mysterious endeavor called Project PX. When they arrived, they were shown the ENIAC. This wasn't a friendly introduction. There was no user manual, none existed. There was no training course, no instruction set, not even a simple login screen. Instead, they were handed a stack of the machine's logical diagrams. These were essentially the blueprints of its electronic brain. And their instructions were deceptively simple: make this machine calculate the trajectory of an artillery shell faster than any human ever could. Imagine the gap they had to cross. On one side, you have a highly complex differential calculus equation. On the other, a 30-ton machine of wires and switches that understands nothing but the flow of electricity. That gap was a chasm, and they were told to build a bridge across it. This wasn't data entry. This wasn't clerical work. It was a monumental feat of translation, logic, and pure creation. They had to invent a new way of thinking. So let's get specific. Let's talk about the backbreaking, intellectual innovation that was so casually airbrushed from the history books. Programming the ENIAC wasn't like typing on a keyboard. It was a physical, 3-dimensional puzzle. Every single new problem required what they called setting up the machine. First, they had to map the logic. They would spend weeks breaking down the mathematical equations into a precise, step-by-step sequence of operations, addition, subtraction, multiplication, storage, that the ENIAC circuits could actually perform. They were essentially creating the world's first algorithms. Then came the physical patch. Once they had the logic mapped out on paper, they had to physically implement it on the machine. This meant manually connecting hundreds of cables between different units on dozens of massive plug boards. It was like being a telephone operator for a system the size of a building. And that wasn't all. They also had to set thousands of individual switches to control the flow of data and instructions. A single program could require over 3,000 precise switch settings. One misplaced cable, one incorrectly flipped switch, and the entire calculation would fail. The setup for a single problem could take them weeks. And then came the hardest part, debugging the impossible. The ENIAC was a primitive beast. It was constantly failing. Of its 18,000 vacuum tubes, one would burn out almost every other day. Finding that one faulty tube was like finding a single broken light bulb in a city with no street map. When the machine produced a wrong answer, it was their job to figure out why. They had to crawl inside the machine, literally, tracing the path of the calculation through the jungle of wires and tubes. Betty Snyder and Betty Jennings became legendary for their methodical, intuitive debugging skills. They developed systematic techniques that are, in essence, the ancestors of the debugging processes every software engineer uses today. They would run test problems, isolate faulty circuits, and develop an almost sixth sense for how the machine behaved. They didn't just run calculations, they invented core concepts that are now fundamental to computer science. To save precious setup time, they created what they called subroutines. These were pre-wired, preset sequences for common mathematical operations that they could plug in and reuse. They were, without exaggeration, writing the world's first software libraries. They developed a practice called programming by diagram, a visual method for thinking about code flow and logic that predates modern flowcharts. They were not simply using a tool that had been handed to them. They were creating the user manual for the digital age, page by page, as they went. So, how does a contribution this fundamental, this foundational, simply vanish? The mechanism wasn't a single act of malice, but a slow, grinding combination of gender bias and institutional categorization. First, despite their mathematics degrees and their groundbreaking work, they were classified as subprofessionals or clerical workers, not engineers. In the rigid, hierarchical world of the 1940s military and academia, their intellect was seen as administrative, not inventive. Their work was the soft part of the project, while the hard engineering of the machine itself was what mattered. Second, when the ENIAC was finally unveiled to the press and the public in February 1946, the Army made a strategic choice. They showcased the hardware, the tubes, the wires, the sheer scale of it, as the achievement. The programming, the invisible logic that gave it life, was considered women's work and was not part of the official narrative. In the iconic photos from that day, you see the men, the engineers and officers, explaining the machine. And you see the women, standing there, their monumental intellectual contribution completely unmentioned. The pictures cemented their role as decorative objects. In fact, on the day of the big demonstration, the women who had programmed the machine weren't even invited to the celebratory dinner that followed. The final blow came after the war. As computing began to evolve, it quickly became clear that programming, what they had called setting up, was the most critical, complex part of the process. So, the field was deliberately rebranded. It was professionalized, elevated, and turned into a high-status, male domain of engineering and science. The technical lectures and manuals about the ENIAC, written by their male superiors like Herman Goldston and Arthur Burks, detailed the hardware but almost completely omitted the women's methodologies, their innovations in programming, and their names. The story that entered the textbooks was of the hardware pioneers, Presper Eckert and John Mauchly. The women who gave that hardware its soul were simply forgotten. Their erasure wasn't an evil conspiracy. It was something far more common. It was the default setting of a culture that was simply incapable of seeing women as technical creators. The legacy of the ENIAC programmers is the invisible architecture of our world. They proved that programming was a staggering intellectual discipline in its own right, paving the way for software to eventually be recognized as the soul of the computer. But for decades, their story was lost. It took until the 1980s, when a young computer science student named Kathy Kleiman stumbled upon those photos and asked a simple question: who are the women? For the record to begin to be corrected. Kleiman spent years tracking down and interviewing the surviving programmers, piecing together their story. In 1997, more than 50 years after their work, they were finally inducted into the Women in Technology International Hall of Fame. Their story is a masterclass in how bias works, not always by actively destroying, but by passively not seeing, not recording, and not crediting. They weren't just programmers, they were the cryptographers of the future. They were decoding a new realm of human thought that was invisible to everyone else, simply because no one thought to look at the women in the room. Who built the logic of your world? There are so many more stories like this one. Share another unsung tech pioneer you know about in the comments below. And for more hidden histories, subscribe to the Unsung.